Hi, I'm Jerry Ellsworth, amateur call sign AI6TK, and this is going to be a multi-part video series on building 160 meter and 80 meter mag loop antennas. There's a lot that I love about the amateur radio hobby. I love building things. I love exploring how far I can get a radio signal to go on the lowest amount of power. When I got started about a year ago, I put up a 20 meter and a 40 meter dipole. It was pretty easy to do within the space that I had, and immediately I started reaching very distant stations, and I had a great time trying to catch those perfect gray line hours where I could get extra propagation. So I was looking for more challenge, and I decided to put up an 80 meter and a 160 meter dipole. Once I got that up in the air, no matter how much power I put into the antenna, I could only reach a few hundred miles away. So I started doing some research, and I found out the dipole antennas are very sensitive to their height above the ground. And as you can see in this simulation, this is a simulation of how high I had my 160 meter dipole antenna. You can see by the red part of the lobe, almost all the energy is going straight up into the air. So when all of your energy is going straight up in the air, it either just leaves the earth and goes off into the ether, or it bounces at such a steep angle that it only comes down a very short distance away. So what you really want to do is get the dipole very high in the air so that the energy is shooting out more lateral so it can strike the ionosphere and bounce further away. So here's a simulation of that 160 meter dipole, about a half wavelength above the ground. You can see the energy is shooting out more lateral, so it will bounce off the ionosphere. But this distance, this critical distance here, is about a half wavelength. That's about 80 meters for a 160 meter dipole, which is just not practical for me, that's for sure. So I started doing some exploration to see if there was another option out there, and I found the magnetic loop antenna. This magnetic loop antenna is less sensitive to the ground effects. And so you can see in this simulation, this is a magnetic loop antenna at 80 meters, about zero height above the ground, and you can see although the energy isn't shooting out as lateral as the dipole at the proper height, there's still a lot of energy shooting out laterally. After building the antenna and learning how to tune it, I started to reach DX on both 80 and 160 meters. I was very pleased. Okay, in today's video, we'll just focus on building the mechanical structure to hold the loop and the loop itself. In future videos, we'll talk about the capacitor that you'll need, discuss some air variable capacitors, some vacuum capacitors. We'll talk about the control system and the auto-tune circuitry that tunes the capacitor for the frequency that you're broadcasting on. I'll have a video on the theory of operation, and I'll have some videos showing actual metrics, side-by-side comparisons of this versus the dipole antenna. Don't let all these fancy CAD models fool you. This was a free-form project from the beginning. We used a lot of found materials, and I made the CAD model just to make this video prettier. So feel free to improvise a little bit. You'll want to find 50 feet of copper pipe. In our case, we found some low-cost 3/4 inch. The bigger the diameter, the better. Resistance is your enemy in a magnetic loop antenna and will reduce your efficiency. You'll cut the 50-foot length in half, and then you'll start to roll it into two 7.5-foot circles. This is really awkward. Don't worry if there's some little wavy bits. You can correct that later. Just be careful not to kink the tubing. You'll be creating a spiral out of the two loops, so you need to space them about 4 inches apart with conduit sections. Next, you'll be stacking the two copper loops together. Use the 4-inch spacers and some household copper wiring to attach the two loops. This will be a little awkward because things will be flopping around quite a bit, But once it's hanging on the frame, things will become much more rigid. The top hanger and the lower brackets are pretty straightforward. The only thing to note is you probably should choose some material that's a good insulator. If you're in a rainy environment, you probably should avoid wood because it may soak up water and become conductive. The bottom loop insulators really tie everything together. Everything becomes very rigid after these are installed. At this point, I tried to adjust the entire loop so everything is square, adjust the copper pipes so they're even, and then smash them flat with a hammer and drill some holes. I even tried to solder the ends closed to keep them watertight. Okay, we're reaching the end of this video. Some of you that are experienced mag loop designers are going to see some of this hardware at the bottom and say, you're adding a lot of resistance to the loop, and you're absolutely correct, but this is intentional. I have a lot of components I'm going to be swapping out at the bottom over the next several videos to illustrate different configurations. So, I hope some of you decide to build along with me, and can't wait to share my next video. Thanks.